Hello dear students. In this video we are familiar with number systems. This is the include in digital electronics. Number system include four type of number systems. First one is decimal, second one is binary, third one is octal, and last one is hexadecimal number. First of all, decimal number system. Decimal number system include 10 numbers, means it has radix or base is 10. It uses 10 digit from 0 to 9. Next is binary number system. It uses 2 digits, that is 0 and 1, and radix of binary number system is 2. Octal number system, it uses 0 to 7 numbers and radix of 8. And next one is hexadecimal number. It uses 0 to 9, and after that 9 from 10 is represent a alphabets, that is A, B, C, D, E, F. That is 0 to 9, and then 10, 11, 12, 13, 14 and 15 with radix of 16. Okay. Next, conversion. One number convert in other number. First one, we are conversion of decimal to binary conversion. Any decimal number convert in binary equivalent. First of all, convert the decimal number into binary conversion is follow a process. Dear students, for the remember D for decimal and D for divide. Any binary number which is convert in decimal number to binary conversion, any decimal number, for example here 32.12, it has two parts, that is integral part is 32 and fractional part is 0.12. Now we want to convert the whole number in binary conversion system. The process is the integer part is divided by the numbers base whose want to be conversion. In our example, binary conversion means radix of binary number system is 2. So we are divide the 32 is divided by 2, that is the base of binary conversion. If example decimal to octal number, then we divide the number by the 8. See here, 32 is divided by 16 and the remainder is 0. Next, the 16 is divided by 2 and the remainder is 0. Next, divided by 2 and remainder is 0. And last, 2 by 2 is 1 and remainder is 0. 1 divided by 2 is not possible. We can write here 0 and here write this 1. This 1 which is last digit, okay, 1. And for the written, we take the MSB from the bottom and LSB as the top. So write the arrow from bottom to up and the right the number is 1, 0, 0, 0, 0 and 0. See here 1, 0, 0, 0, 0, 0. It means this 0 is represented as LSB and this one is represented as MSB. So we can say 32, that is the decimal number, is equivalent to binary this number with the base of 2. And for the fractional part, we are multiplied by the binary number system radix, that is 2. Okay, our fraction part is 0.12 is multiplied by 2, so we get the 0.24. Here the whole number is 0, so here write whole number. Next, the fraction part in this number is 0.24. Is 0.24 is multiplied by 2. We have the whole number is 0 and the fraction part is 0.48. Write here 0 and the fraction part is multiplied by 2 again. and we get the 0.96. Whole number is 0 and the fraction part is 0.96 is multiplied by 2. We get the 1.92. Here 1 is whole number is right here and 0.92 is multiplied by 2 is equivalent to 1.84. Write whole number here and the fraction part is multiplied by again 2 and we get the 1.68. 1 is right here and 0.68 is multiplied by 2 again. At least 4 to 5 decimal points we are getting. Okay, but write here the number from MSB to LSB. This is opposite to the integer part. Okay, this is MSB hour and this one is LSB. So write here for LSB, that is 1 1 1. When we write the data, start from MSB and end at the LSB. So MSB is 0 because it is fraction part, so we start from decimal point and write here 0 0 0 and then 1 1 1. This is the equivalent decimal binary equivalent of 0.12. It means the whole answer of 32.12 base of 10, that is it is decimal number and we want to convert in binary number, and that is the whole number and that is the fraction part. This whole number is equivalent to 1 0 0 0 0 0 and point, this is equivalent to 0.12 in binary. This is process of any decimal number convert in any other number system. This is example for binary. Next example is decimal to octal conversion. डेसिमल टू ऑक्टल कन्वर्जन स्टूडेंट्स, जैसा कि हम पहले भी देख चुके हैं, क्या मेथड है डेसिमल टू ऑक्टल कन्वर्जन. डेसिमल से अदर नंबर कन्वर्जन सिस्टम में हमें जाना है, तो डेसिमल से याद रखिए D फॉर डेसिमल एंड D फॉर डिवाइड. मीन्स हमें डिवाइड करना है, किससे करना है, जिस नंबर सिस्टम का कन्वर्जन जिसमें हमें जाना है. डेसिमल में हमारा क्वेश्चन दे रखा है, हमें ऑक्टल कन्वर्जन में जाना. इट मीन्स वी आर डिवाइड द गिवन नंबर बाय द बेस ऑफ ऑक्टल नंबर, दैट इज 8. इन एग्जाम्पल हेयर कन्वर्ट डेसिमल नंबर 27 is base of 10. It means it is decimal number into its octal number. Octal number is base of 8. So process is 27 is divided by base of 8. So 27 is divided by 8 and here write remainder. Okay, and 3 is question, 3 divided by 8 is not possible, 3 is remaining, so 3 and the for whole number or integral part we write MSB and LSB. So 3 from bottom to up, so write here 3 base of 8. This is our answer. This is decimal to octal conversion. Okay, next example is also 47.3 is base of 10 and what is the conversion system of octal number. Same process, 47 is divided by 8 and 0.23 is multiplied by 8. Here divided by 8 we get 7 and 5, that is from bottom to up, that is 57 octal number. And what is the 0.27 decimal number in octal number system? We multiply by 8. 0.23 is multiplied by 8 is equivalent to 1.84. 1 right here and 0.84 fraction part is again multiplied by 8 and we get 6.72. 6 is whole number is right here and 0.72 is multiplied by again 8 and we get the 5.76. 5 is whole number and 0.76 is fraction part. If after 3 points, after whole number point decimal number we get the 3 points is sufficient. That is the right here for fraction part MSB to LSB or top to bottom. So 165, right, 165. So we get the answer 0.23 is 0.165 and the whole answer of this question is 47.23 in decimal number. In what, that is octal number conversion, we get the 57.165. that is our conversion. It means decimal to binary conversion. Okay, next example is decimal to hexadecimal number. Decimal to hexadecimal number means we are divide the decimal given number by the base of hexadecimal number system, that is 16. So for example, 564 base of 10 to its hexadecimal number system means 564 is divided by 16, that is the base of or radix of hexadecimal number, means divided by 16 we get the 35 equation and remainder is 4. 35 is divided by 16 we get the 2 and remainder is 3, and 2 is divided by 16 is not possible, so write here 2 and 3 and 4. For the integer part we write from bottom to top, so we write 2 3 4, so answer is 2 3 4 base of 16. Okay, next example is integer part with this is the fraction part. So the procedure is same. 268 is divided by 16 because hexadecimal conversion we want, so divided by base of hexadecimal number system, that is a 16, and 0.14 is multiplied by 16 for conversion of decimal part of the decimal number. 0.14 multiplied by 16 and we get the 2.24. 2 is whole number is right, and again 2.24 is multiplied by 16, again we get the 3.84. 3 is whole number on integer, and the fraction part is 0.84. 0.84 is multiplied by 16, we get the 13.44, means 13 is right here and 0.44 again multiply by some number. If with 3 points after decimal number we get the 3 points, means from MSB to LSB. MSB here top and LSB is bottom. It means 2, 3 and 13. In 13 hexadecimal number we can say D, A, B, C, D, then to F. Okay, it means it is D. So answer is 0.14 decimal number system is equivalent to 0.23D. It is our decimal conversion number system.